Lesson 3.2c. Lesson 3.2c, we're going to work on word problems that are going to involve solving triangles. The first problem you actually should find very familiar. So we're going to put up, first of all, I'm going to put up the three steps to solving word problems that involve trigonometry. Then I'm going to put up the first word problem. After that, we're going to solve it. Like I said, it should look very familiar to you. Step 1, draw and completely label the picture. Step 2, write an equation describing the picture. Step 3, solve the equation and put your answer in the correct units. In order to solve this problem, we first need to describe what an angle of elevation means. An angle of elevation, I'll put up the definition now, is the angle of a line of sight above the horizontal. So if I was looking going like this, my angle of elevation would be 0. And as I go like this, the angle of elevation would go up. Now the opposite of angle of elevation would be a 90-degree angle of elevation would be if I was standing straight up in the air. The opposite of angle of elevation is angle of depression. So an angle of depression is, put the definition up again, there it comes. Oh yeah, look at it go. Okay, angle of depression, like the definition just said, is the angle down from the horizontal. So if I was standing on top of a mountain looking down at a village, or if I'm on an airplane looking down at the runway, that would be an angle of depression. So we're going to start this problem by starting with step 1. Step 1 is draw the picture. Now the picture we have Shelly, we have the flagpole, and we know how tall Shelly is. We don't know how tall the flagpole is. So first we draw Shelly. She's happy. Oh, it's a her. Yay. Okay, there's Shelly. And we know that she's standing at eye level 123 feet from the flagpole. The flagpole's here, starts on the same ground. Here's our pretty flag, put a nice flag on it. Okay, there's our flagpole. Okay, and we know her angle of elevation if she looks up at the top of the flagpole. And we know that angle of elevation is 26 degrees 40 minutes. What we would like to find is the height of the flagpole. Okay, and that's only going to mark from here to the top. Okay, so that's step 1. We've drawn and labeled the picture. Now for step 2. Step 2 is to make an equation based on that picture. Well, here I know the angle, the adjacent side, and I want to know the opposite side. So I'm going to be using tangent. So my equation is going to have tangent in it. So I'll go ahead and make that over here. We know that the tangent of 26 degrees 40 minutes is h over 123. Now it's algebra to solve that equation. I multiply both sides by 123. I get 123 tangent of 26 degrees 40 minutes, okay, equals h. And this is everything's measured in feet, so we're going to be using feet. So here's my calculator right here, and I just type it in exactly like that. 123 times tangent 26. Don't forget the angle menu, degrees, 40, angle menu again, minutes. Just like that. Just like that. And there's my answer. The answer is 76.8 feet. So I put 76.8 feet as h. But that's not my final answer because I have to add her height, which was 5.3 feet. So I do the 76.8 plus 5.3. That gives me 81.1 plus 82.1. The flagpole is 82.1 feet tall. Okay, for those of you who did the project, that should have been a very familiar problem. Here's the next problem. Buildings, angles of elevation, sunlight. Step one is always the same. Step one, draw the picture. So the first thing I'm going to draw is the sun. Here's the sun. So there's the sun. The sun makes some angle of elevation. So the sun makes some angle of sunlight down to the ground. Okay, so at this point of the ground, there's also this building. Here's my building. It is 3.0, I'm sorry, it's 34.09 meters tall, and the shadow it makes is 37.62. So this, the place where the sun, you can't see the sun from underneath the building, that would be called the shadow. And it is 37.62. And I want to find the angle of elevation, which is theta. So now that was step one. Step two, write an equation. So again, we have the opposite and the adjacent sides. So we're using tangent. Only this time we don't know what theta is, so we're going to be having to use inverse tangent because that's how you find theta. So we use tangent of theta equals the opposite, which is 34.09, divided by the adjacent, which is 37.62. Okay? And that's it. So we're going to we divide 34.09 by 37.62. That gives us 0.906. So tangent okay, now in order to get the angle, we have to use inverse tangent. So I put inverse tangent of 0.906. That one's going to give us the answer. In this case, the answer is not going to work because it's negative. The answer is 42.17. 18, I should say. So, and there we go. Very similar, only this time we're finding the angle instead of the side. Now I'm going to show you a new type of problem involving something called bearing. So before we can even do that problem, it's very important that we understand what bearing is. Bearing is a navigation thing. So think about a map and looking it down on a map. The bearing is the angle that you are away from north. So if something was straight north of you, then the bearing of that thing would be 0. If something was straight east, then it would be 90. If the bearing was 180, it would be directly south, and if the bearing was 270, it would be directly west of you. Okay, so it's all about the angle that you are away from north. So the question asks, what would the bearing be of something that's -2, 4? So first of all, step one, draw the picture. So I draw a coordinate plane. And on that coordinate plane, I'm going to draw the point at -2, 4. So that's going to be -2, 4, 1, 2, 3, 4. 4 is going to be about right there. And I want to know what bearing that is from me right there. So what I have is I'm on this bearing line. And I would like to know this angle, because that's the degrees you are away from north, which is up here. So how do we find that angle? Well, it would be helpful. We know if I start at north and I go all the way around to west, that's 270. So if I knew what this angle was, right there between west and my angle, then I would know that it would be 270 plus whatever that angle is going to give me my bearing. So, but we can find this angle. We know that this triangle here, and I'm going to go ahead and erase the little arrows. Trying to find that green angle, and we're going to add 270 to it to get our bearing. Okay, we know this is a triangle whose sides are 2 and 4. So again, we're going to use trig, and again, they're trying to find this angle theta. Okay, and we're going to be using tangent because we know the opposite side, the adjacent side. We don't need to know the hypotenuse. So the tangent of theta equals 4 over 2. Well, 4 over 2, that's easy enough. 4 over 2 is 2. So now we just have to use inverse tangent of 2. That's 63.43. We'll say 63.43 degrees. So 63.43 degrees is this angle. But that's not the bearing. Remember, the bearing we have to go all the way around. So not only do we have the 63, but we also have the 270 on top of that. So we take the 63.43 and we add 270 to that. That gives us our bearing of 333.43. So the bearing for this particular point would be 333.43 degrees. Okay, if you make the bearing be a 360-degree angle, you don't have to talk about where it is in relation to east, west, south, or north. You can just say the bearing is 333. This is what they do on airplanes. Listen to the air traffic controllers and stuff like that, and you'll see that. Okay, those are the 3 types of problems we have to do. That's the end of the lesson, and we'll have work to do next class. Don't forget, this is the last lesson. So coming up early next week, the first grade you have in 3rd quarter is the test on this. Okay, bye.